A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
I was reading through some of the findings from the International Conference on Learning Representations that happened back in January, and it feels like the honeymoon phase of the agentic AI boom is officially over. We have spent the last year just throwing more agents at every problem, thinking that if one agent is good, 10 agents must be a genius-level workforce. But the data coming out of 2026 is telling a much messier story.
It is the coordination depth wall. I have been obsessing over this for weeks. Hello, I am Herman Poppleberry, and I think we are finally seeing the limitations of what I call the flat topology dream. Today's prompt from Daniel is about exactly this shift. He is asking about the transition from those single-layer orchestration models to what is essentially AI middle management.
It is funny because we spent decades trying to flatten human corporate hierarchies, because middle management was seen as this bloated, inefficient layer that just slowed down communication. And now, according to Daniel's prompt and the recent research, we are realizing that for AI agents to actually function at scale, we have to build the very bureaucracy we tried to escape.
The irony is not lost on me, but the technical necessity is undeniable. That ICLR research from January 31st showed that when you have a single orchestrator trying to manage more than 5 specialized agents directly, the system basically suffers a nervous breakdown. They call it the coordination depth issue. Latency does not just increase linearly, it explodes. And context drift becomes almost a certainty because that single orchestrator is trying to hold too many distinct state threads in its head at once.
I love the idea of an AI having a nervous breakdown. It is basically the digital equivalent of a manager who has 20 direct reports and spends their entire day in back-to-back meetings until they start forgetting which project is which. But why 5? Is that just an arbitrary benchmark? Or is there a specific mechanism that breaks down at that number?
It is tied to the quadratic growth of potential interactions. If you have 5 agents and 1 orchestrator, the number of communication paths is manageable. But as you scale, the orchestrator has to perform what we call context reconstruction for every single handoff. It has to take the output of agent A, summarize it, verify it against the global goal, and then formulate a specific instruction for agent B. When you exceed 5 specialized agents, the token cost and the sheer cognitive load on the orchestrator lead to what is known as the ON² coordination tax. The cost of talking about the work starts to outweigh the value of the work itself.
So, we are moving toward a world of sub-orchestrators. Daniel's prompt asks if these middle-layer agents have a formal name yet, or are we just calling them digital shift leads?
There is a bit of a naming war going on, which is typical for this field. Crew AI has really pushed the term manager agents. They have standardized this idea of a manager that owns a specific subdomain. If you look at LangGraph, they prefer the term supervisors. But if you want to sound like you have been reading the latest academic papers, the hierarchical macro-micro framework, or HiMAC, which was just published this March, calls them meta-controllers.
HiMAC. I assume that is pronounced HiMAC.
That is the consensus. The HiMAC framework is really the gold standard right now for defining how these layers interact. It treats the top-level orchestrator as the strategist that handles macro actions, while the meta-controllers or middle managers handle the micro actions.
It sounds fancy, but let us look at the practical side. If I'm building a system to, say, handle an entire legal department's intake process, how does the communication actually flow? I mean, I assume we are not just passing a massive JSON file back and forth and hoping for the best anymore.
No, that is where the stateful multi-actor coordination comes in. The big shift in 2026 is the move away from simple message passing toward a more structured agent-to-agent protocol, or A2A. The A2A protocol uses things called intent headers. Think of it like a formal cover sheet for a digital file. Instead of just sending a block of text, the worker agent sends a packet that explicitly states its intent, the tools it used, and a confidence score for the specific output.
So it is like a status report that the middle manager can actually parse without having to reread the entire document.
That is the core of it. And the middle manager performs a task called context reconstruction. Instead of passing the entire transcript of the worker agent's internal monologue up to the CEO agent, the middle manager compresses that output. It extracts only the relevant facts and the state changes. This is how we defeat that coordination tax. We keep the top-level context window clean by having these middle layers act as filters and synthesizers.
I can see why that would save on token costs, but does it not introduce a huge risk of the middle manager playing a game of telephone? If the manager agent misinterprets the worker agent's output, the top-level orchestrator is getting a summarized version of a mistake.
That is a legitimate concern. That is why we are seeing the rise of what are called verification gates at the middle management layer. One of the emerging best practices is to never have a worker agent report directly to a manager without a critic agent or a validator agent in the loop. These are specialized sub-agents whose only job is to audit the worker's output before it ever reaches the manager. It stops the hallucination snowballing effect. If the worker agent makes a mistake, the validator catches it at the micro level before it becomes part of the macro strategy.
It is interesting that we are building these systems to be more and more like human hierarchies. I mean, we are essentially saying that AI is so powerful that we need to build a bureaucracy to keep it from lying to itself. But you mentioned something about the Model Context Protocol, or MCP. How does that fit into this middle management layer?
The Model Context Protocol is crucial for security and efficiency. In a flat model, every agent usually has access to the same pool of tools and data, which is a nightmare for governance. In a hierarchical structure, the middle manager uses MCP to grant subagents very specific, time-limited access to tools. If a worker agent needs to search a specific database, the manager provides the bridge through MCP. The worker never sees the full system state. It only sees what it needs for its specific micro-action.
That makes a lot of sense from a security standpoint. You do not want your junior research agent having the keys to the entire enterprise database. But let us talk about the results. Does this actually work, or is it just more complexity for the sake of complexity?
The numbers are pretty staggering. The HiMAC paper I mentioned from earlier this month showed that by using hierarchical decomposition, they saw a 19.6% improvement in task success rates over flat systems. That is nearly a 20% jump just by changing the architecture, not the underlying models. It turns out that when agents have narrower scopes of responsibility, they are significantly less likely to wander off track or get caught in logic loops.
20% is massive in this context. But there is a flip side, right? I saw a study recently by Jeremy McIntyre in CIO magazine. He looked at these hierarchical agent organizations and found that they actually fail 36% of the time when they are poorly designed. He basically said that we are automating human organizational dysfunction. If you build a bad hierarchy, you just get a faster, more expensive version of a bad company.
McIntyre's study is a necessary reality check. The failure rate usually comes down to what he calls state leakage. If the boundaries between what the manager knows and what the worker knows are not clearly defined, you get these weird feedback loops where the agents start arguing over who has the most recent information. It is why the design for deletion philosophy is becoming so popular.
Design for deletion. That sounds like something a minimalist architect would say right before they take away your chair. What does that mean in an AI context?
It was popularized by Anthropic and a few other firms like Rhesus AI back in February. The idea is that we should build these middle management layers to be collapsible. We know that models are getting better and context windows are getting bigger. In 2 or 3 years, a single model might be able to handle 10 agents worth of work without breaking a sweat. If you hard code a complex hierarchy today, you are creating massive technical debt. Design for deletion means building your orchestration logic so that as the models get smarter, you can just remove the middle layers without having to rebuild the entire system from scratch.
So it is a temporary patch. We are building the bureaucracy because the current models are not quite smart enough to handle the scale on their own. But we are hoping that one day we can fire the middle managers and go back to a flatter structure.
That is the central debate right now. It is the latest version of the bitter lesson. You have people like Boris from the Claude Code team at Anthropic arguing that these multi-agent hierarchies are just a crutch. They think the future is monolithic, where one massive model with a multi-million token context window just does everything. But then you have the enterprise side, people at IBM and BCG, who argue that hierarchy is not about model limitations, it is about governance.
I think I am with the enterprise folks on this one. Even if a model is smart enough to do everything, do you really want it to? If something goes wrong in a monolithic system, it is impossible to audit exactly where the logic failed. But if you have a legal review manager agent overseeing a compliance agent, you have a clear paper trail. You can see exactly which agent failed and why. It gives you a level of accountability that you just do not get with a single black box.
That is exactly the point. Hierarchy provides auditability. It allows us to treat AI agents as synthetic talent. When PwC launched their Agent OS earlier this year, that was their whole pitch. They are not selling a chatbot, they are selling a way to manage a digital workforce. And you cannot manage a workforce without a structure. You need those meta controllers to act as the interface between the human executives and the thousands of micro actions happening at the bottom of the stack.
Synthetic talent. That is a heavy term. It makes me wonder if we are actually solving problems or if we are just creating a new class of problems. If these agents are mimicking human organizational structures, are they also going to start having digital office politics? Is the legal manager agent going to start prioritizing the reports from its favorite compliance agent?
It sounds like a joke, but in a stateful system you can actually see versions of that. If an agent's output is consistently ranked higher by the validator, the manager will naturally start to rely on it more. We have to be careful that we are not just baking our own biases into the orchestration logic.
Let us get into some of the actual frameworks people are using to build this stuff right now. You mentioned Microsoft AutoGen 2.0. I know that just came out this month. What are they doing differently for hierarchies?
AutoGen 2.0 is a huge step forward because it is async first. In older versions, the orchestrator would send a task and then just wait for the response. It was very synchronous and very slow. The new architecture is designed specifically for these hierarchical group chat managers. It allows for asynchronous communication between different branches of the hierarchy. So while the legal subteam is working on a contract, the finance subteam can be running an audit simultaneously. The top-level orchestrator only steps in when both branches have completed their microtasks and reported back to their respective managers.
So it is true parallel processing for agentic workflows. That actually sounds like a real productivity gain rather than just a way to manage token limits. But if I am an engineer listening to this and I'm currently hitting that wall, I have got 5 agents and my system is starting to get flaky. What is the first move? Do I just pick one agent and promote it to manager?
Not quite. The first move is usually to implement a critic or validator agent. Before you add a whole new layer of management, you need to ensure the quality of the microtasks. Once you have a validation step in place, then you look at your agent pool and see where the natural clusters are. If you have 3 agents working on data retrieval and 2 agents working on analysis, you create a meta controller for each of those clusters.
And what does that meta controller actually look like in code? Is it just a model with a very specific system prompt?
Mostly, yes. But the system prompt has to be fundamentally different. A worker agent's prompt is about execution. A manager agent's prompt is about delegation and synthesis. It needs to know how to evaluate the output of its workers and how to decide when a task is actually finished. That is where a lot of people fail. They give the manager agent the same tools as the workers, and then the manager just ends up doing the work itself instead of managing.
I have worked for that guy. It is the classic micromanager trap. The manager agent thinks it can do a better job than the sub-agent, so it just takes over and you are right back to square one with a single layer bottleneck.
It is a common failure mode. The best practice is to strictly limit the tools available to the manager. The manager's only tools should be delegation tools and synthesis tools. It should not have access to the raw data or the execution scripts. Its only way to interact with the world is through its workers. This forces it to be a manager.
That is a brilliant way to enforce the hierarchy. It is like a physical constraint on the software. But what about the latency? If I am adding a manager and a validator, I am adding at least 2 more model calls to every single task. Does the efficiency of the hierarchy really outweigh that initial delay?
In a long horizon task, yes. If you're doing something that takes 30 seconds or a minute to complete, adding 2 seconds of management overhead is a bargain if it increases your success rate by 20%. The latency explosion that the ICLR paper warned about happens when you do not have a hierarchy. When a single orchestrator is trying to manage 10 agents, it might take 5 or 6 attempts to get a clean handoff because of the context drift. A hierarchical system might have more steps, but each step is much more likely to succeed the first time.
So it is. The old slow is smooth, smooth is fast principle. We are trading raw speed for reliability and scale. I can see why enterprises are jumping on this. They do not care if a report takes an extra 10 seconds as long as it is actually correct and they can prove how it was generated.
Reliability is the only thing that matters at the enterprise level. We are past the point where a cool demo is enough. If you want to deploy an agentic system that handles millions of dollars in transactions or sensitive legal documents, you need that governance layer. The HiMAC framework and the A2A protocols are the building blocks of that reliability.
It feels like we are watching the industrialization of AI. We went from these artisanal, handcrafted scripts to these complex hierarchical factories. It is a bit less magical maybe, but a lot more functional.
It is the natural evolution of any technology. We start with the simple version, we find the limits, and then we build the infrastructure to push past those limits. The middle management layer is just the next logical step in making AI agents actually useful for complex real-world work.
I wonder what the next step after that is. If we have middle managers, do we eventually get digital unions or a digital board of directors?
We are already seeing the board of directors model in some of the more advanced multi-agent systems, where you have a group of high-level orchestrators that have to reach a consensus before a major action is taken. It is all about building in checks and balances.
It is a bit wild that we are spending all this time and energy recreating the very structures that we often complain about in our own lives. But I guess those structures exist for a reason. They handle complexity in a way that a flat group just can't.
Complexity is the keyword. As the tasks we give these agents become more complex, the systems that manage them have to evolve. The transition Daniel asked about is not just a trend, it is a technical requirement for the next phase of AI.
So, for the folks listening who are building these systems, what is the one thing they should take away from this?
I would say the most important thing is to audit your coordination tax. If you find that your orchestrator is spending more than 30% of its tokens just summarizing and re-explaining tasks to other agents, you have hit the wall. You need to stop adding workers and start building a hierarchy, and use the HiMAC principles. Break your tasks into macro and micro actions.
And maybe don't forget the design for deletion part. Don't get so attached to your digital middle managers that you can't fire them when the models get smarter.
That might be the hardest part. Once you build a complex system, it is very tempting to keep adding to it rather than simplifying it. But in this field, simplicity is usually the ultimate goal.
I think that is a good place to wrap up the technical deep dive. It is a lot to process, but it is clear that the way we think about AI orchestration is fundamentally changing. It is not just about the model anymore. It is about the architecture.
The architecture is the model now, in many ways. How you structure the conversation is just as important as the weights of the LLM you are using.
Well, I feel like I need a middle manager to summarize everything you just said for me, but I think I have the gist of it. We are building digital bureaucracies to save us from digital chaos.
That is a pretty accurate summary.
Before we go, we should probably do the usual housekeeping. This has been My Weird Prompts. A big thanks as always to our producer Hilbert Flumingtop for keeping the gears turning behind the scenes.
And a huge thanks to Modal for providing the GPU credits that power the generation of this show. Their serverless infrastructure is actually a great example of the kind of efficient scaling we have been talking about today.
If you're finding these deep dives useful, or if you just like listening to a sloth and a donkey talk about meta controllers, please leave us a review on your favorite podcast app. It really does help other people find the show.
You can also find us at myweirdprompts.com for the full archive and all the subscription links. We are on Spotify, Apple Podcasts, and pretty much everywhere else.
We'll be back soon with another prompt. Until then, keep your context windows clean and your hierarchies collapsible.
Goodbye.
See ya. Yeah.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, my weird prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My weird prompts, that's the flows from sloth.